Hello everyone. In following of our G code programming lab sessions, today we will have the simulation lab to see how we can use these G codes in the real environment. So we will use simulation to see how these codes will work with the CNC machines. So this is the machines that we are working with it, and this is the program software that you know how to download and install it. I also put you the tutorial for installation, so you don't have any problem to install it, and you are supposed to do your homeworks with this software. But as it's trial version, it has just 2 weeks and it's totally enough for you to do your homeworks and submit. So now we will start to first of all get familiar with the device. So first of all, if you want to get close or roundabout this device, if you click right click, you will see this enlarger. If you move your mouse upward, it will go zoom in, and if you come backward, it will be zoom out. And if you just go left and right, you can just rotate to see your specimen inside the device from any angle. So this is the first thing. And even with the this one, you can also change the position of the uh, view part. You can see the device actually. So how you want to make it, you can up and down, left and right. You can change the view of the device. So as you can see here, this is a spindle we have here. So, and here, as you can see, we have stations. So here there are stations that you can define your tools. Station 1, 2, 3, 4. So this device actually is equipped by 4 stations. And here, as you can see, this is the jaw that will hold your specimen in order that the CNC machine will work on it while it's holding very tight the specimen to avoid any disruption. So in the right part, we have analog. Actually, we have the real analog near to the device, but also here as a simulator. You can see we have three main axes here, Z, X, and Y. So as you can see, we have here three different types of moving of the spindle, of this arm of the spindle, slow, medium, fast. And here is continuous. It means when you click on this and when you press the Z, you will just hold it. No need to click it every time. And here we have different uh, measures of the moving. So as you can see, the C is 2.54 millimeters, and it means it's very fast. B is a little, and A is very accurate. Actually, whenever we want to specify the coordinate at the last step, we will use A because this is the reliable point. However, we will see in this tutorial how we'll work these things. So as you can see, I just wanted to show you virtually that now I want to move my z-axis to see what will happen for the device. As you can see, this is my z-axis. This is just up and down. Yes, and this is the x, for example. Let's see how x will work. So you see x is this. It will come left and right from the top if you from the in front if you want to see, and from y-axis it will move from the side. You can see it. This is the y-axis. So freely you can move in these three main axes to do the job. And here we have a home button. If you press it, it will ask you home or quick home. Both of them will return back to the zero coordinator of the machine, but the zero coordinator of the machine is not our 0 point. So before starting any operation on a specimen, we need to define our own coordination as a 0 points. So as you can see now, the machine is returned back to the home position. By the way, if you see, this is a shield for safety. If you double click on this shield, the shield will be open. You can see inside more clearly, but while the device want to start, you should close it, because without closing it, the program will not start and the machine will not start, because whatever you do here, actually is happening in the real machine, and the machine is the same shape as you can see here because it's the exactly same simulator of the main machine. So again, if you double click on it, the shield it will be closed. So uh, now today, as you see, we want to make this a map. Actually, I want to make this map on our specimen with this diameter of our specimen. So the height is 60, weight is 80. So we should add this diameters into the program in order to make our specimen for starting to make this shape. So let me go to the so where we can add our specimen here in this position. In this case, we will come for a setup, then we will come for stock and visit. So here, this is the same actually. This is a jaw that will hold your specimen, and according to the size that you give it, it will be appear here. So according to the map, the length is 8 centimeter or 80 millimeter. Uh, Let me add it. I will make it length 80. Wide is 60 millimeter. 60 millimeter. Our height is not mentioned there, but as we talked it in the class before, we'll make it as a 70. And here you have select the widths if you want to make it manual or if you have a dual axis or dual arms, but here we have just only one arm, so we will use just single axis. Be careful that this should be on single axis because we have just one arm. So and then we will click OK, and now the specimen is ready here, and this is also you can see it from top view from here. So this is our specimen for us is here ready to work on it. So this was the first step. We make it much better. So the specimen also color, you can change it if you want, for example red, green, yellow, whatever you want, but we will see during the process if we need to change these colors. So the next step, when I look to this map, what kinds of tools we need? I just need one tool to draw this yin and yang sign actually, and I need to make two holes by drill. So this one, it can be done by a mill, end mill, and these holes can be done by a drill tool. So I need to define two tools, and also the diameters for the drill is here for you is given 10 millimeters should be the dimension of your drill tool, and for the end mill we will make it because it's a very narrow shape, we will make it specified as a 2 millimeter. I think it will be enough. So how we can define a tool? So because see here we don't have any tool, just one default tool in the spindle. I need to define one more. So in order to define our tools, we will come to tool, setup library. Here you can see the number of the tools is here, but we have only 4 station here in this device. So the first one actually it's 2 millimeter flat. I did it before. It is an end mill. You should just click it on end mill, and 2 millimeters is enough for us. And here, don't forget, you will assign which station this tool should be positioned. So it will be on a station 1 and it's already in the device. You see here spindle is already here. But if you have opened it, the software for the first time, maybe it's empty and you need to define the tool number 1 by 2 millimeter flat, but diameters of 2, it means 2 millimeter is the width of this head. From here to here is 2 millimeter. And be sure that is end mill, and it should be located in station 1. And then you will click apply. Then I need a second one as a drill according to the shape. As you can see here, it was I don't know why it's not showing for me. Let me try to open it. Yes, now it's working. as you can see, it's 10 millimeters, the diameter of the drill. So 10 millimeter drill is 10 millimeters. It should be located to station 2. So you can just change the station here. It's better to be after station 1. And you will click apply. And then I will click OK. So, but you see, still station 2 is empty. So we should make it happen to come and located in this station. How? We will again click on the tools. This time we will come for configure ATC automatic tool changer. We will click on this. So as you can see, for the station 1, I already defined my first end mill here. And for station 2, we will come here and we will click the tool number 2. And in use is number 1 because number 1 is in the spindle. So for this reason, this is a check mark here. And when I assign the station 2 tools, I will click OK, and immediately you see it will appear here and waiting for the rest of the operation. So now we are getting actually close to get ready, but the first important part after designing the tools and specimen is to assign our 0 point. So where is our 0 point actually? Because when this is our specimen, our 0 point should be defined from this corner. So we should define this corner of the specimen 0, 0, 0. X, Y, and Z, all of them will be 0. So it means this corner, as you can see. This will be our 0 point, and we should define it as our 0 point. So in this case, we have some operations. We will make it together, and let's see how we can make this point as our own 0 point. So first of all, the easiest one is better to start with the Z. So I will go with fast speed and continuously because I'm so far from the specimen. So I'm coming down. I will try to locate it to this left bottom corner. So as you can see, we should also use the y-axis to get closer to the specimen. Just let me get sure that the specimen is not attaching. No, it's good. Okay, now I'm in the left bottom corner positions. Yes, we're getting close. Then I will choose by the x-axis to get close. So because I just wanted to make the Z part, I need to become under the shape, as you can see. Let me just make it with this one to change the position. That see how we can. So the best way if you to use this hand to change the angles to see where you can see a clear square, not a 3D square. In this case, it gives you the best side of view of your position, like here. So because I'm getting closer to the specimen, I will reduce my speed to the medium and also the decimals of my speed movements because it's so critical now. I will get closer. Then when you get very close to uh, the specimen, we will always keep going with the A because it's a very, very, very precise distance. So we will come with this one. It doesn't matter is it fast mode or slow. When you put it on A, you see the movements of the arm is very, very slow. So in real, I told you in a real scenario, you cannot just come and touch the specimen because the specimen will damage or scratch. So how they do it in the real workshops, they will make assign this distance between the end of the tool till the surface of the specimen. They make it as a height of the height of the uh, paper, and the height of the paper is 0.002. You can assign it like that, but sometimes they will put a paper here and the operator start to coming down and the paper is moving till it will stick between the tool and the surface. That will be the 0 point in a real way, but normally you can use 0.002 as exactly is a height or depth of the paper. But here, because we simulate, we should keep going till we touch the specimen till we reach to the error of impaction. So now I'm so close. Yes, you see, impact is happen. So it means that this is the lowest distance between the tool and the specimen. As you can see, let me just make it a little uh, further. So this is my z point. You see, z is now is on minus 106.413 millimeter for this specimen. I need to define this z as a 0. So I will right click here. I will go to the set position, and in z I will make it as my 0 coordinate, and I will click OK. So z is now is get 0 in this position for me as my z0. The second, we will go for x and y. So in this case, I need to just go back a little fast continuously to up. So first of all, let me go for x. So when I go for x, I will go to the side of the x-axis here. Then I will come down. It's enough. Let me just make it a little. Oh, it's get too much. So I will make it. You see now you see a clear square here. So it's a good position to move on. Then because I'm so close, I will click on A and I try my best to get close to the tool side. So the movements is very slow. Again, we will keep going to get the impact error. So this is my X 49 per 641 millimeter. Again, I will right click here. I will put set position and my x's will be 0 for me here, and I will click OK. Does it correct? No, here there is a point. What's the point? Because this mill that we are choosing and we want to work with it, you see, it's not on the surface now. So it cannot be our 0 point. Where it can be in a 0 point, when half of this mill, it will be on the surface in that case. So because it's 2 millimeter, what number should I write here in order to make it as a correct 0 coordination for x for us? Of course, because when it get 2 here, just 1 it will be on the side top of the specimen, and the other one it will be outside of the specimen, and exactly this corner it will be in the middle of this tool. So in this case, instead of 0, I should put -1. -1, because it will be half to the out and inside of the specimen. So this is, we did it for x. Now only the y is remain. So for y also, uh, I want to make it as a good position. It's not sometimes easy to work, but it's fine. So for y, I will make it to the continuous to make it fast. So this is enough. Then I should go a little right part to the right side. Okay, and for y, you should go to the side view of the specimen. Again, getting close till you can see just only a good angle of the specimen. You should just only see a clear cube like this. So now I start to get closer to the specimen. When I get so close, I will reduce my speed. Then when I got so close, I will make it for A. The point you finding by the impact error, it should achieve by A. Otherwise, is not be your 0 point. So again, I will keep going till I receive the impact. Oh, I'm sorry, I'm just clicking on the X. It should be on Y. So I will get close to the so the impact occurred. I will select OK. For Y is minus 113.865 millimeter. Again, the same scenario, it will apply for the Y because again the diameter has 2 millimeter wide. Half of it should be on the surface and the half it will be outside. In this case, it shows us a correct 0 position. Also, Y it will be minus 1, and I will click OK. So now let's check that it can work correctly. So let me first make it here. So how you can go check your coordinate is working well as a 0 point? You will click here to see how it's work. I will go to 0, 0, 0. Here you should put all of them 0, 0, 0, and 0. And then I will click OK. Let's see the impact is occurred because I'm so close to this. I should go a little up. Yes. Now after that we can, let me make it a little far to see the movements of the device. Yes. So now from here we will go to again 0, 0, and 0. Then I will click OK. So you see the, so now this is our, you see, it's a so correct position for us. Look here, if I can zoom more. Yes, this is our ideal position of the 0 point. As you can see, the half of the spindle exactly it's on the edge of the bottom left. Now everything is ready for us to start our uh, model here that we can have. This is model, this design, we want to make it on our specimen. Don't forget, if you click the home button, this button will return back to the 0 position of the device, which as you saw it on the beginning. It was far from this point. But this point, we define it as our own R00. So it is a difference between R00 point and this home button. This is home button for the machine actually. It will return back to the first position that you saw when you open the software. So by the way, if you need sometimes to see the another views from here, left part, you need to click on here and make it as a right part. So here you can see a top view of the machine. If you need to check and see your specimen from the top, this is a top view. If you can see, yes, your specimen is here under the spindle. Sometimes if you needed to check something from the surface, you can use this top view. You can go again, hold the right click and go forward and backward. It will zoom in and zoom out if you need to check everything from the top view actually. So because now I don't need it right now, I will return it back to its position. So what should I do now? I need to open uh, a program. So you can use this blue paper here, and or this file as a new. So this is your program page to write the G code in order uh, the machine will start to work. I don't need it that much. This amount is enough for us. I prefer to make it bigger for our machine view. So now everything is ready, but before that we want to start. I want to just give you some hint. From here you can change the tools by clicking here. For example, now the station 1 is in use. I said, for example, go for station 2. Take the tools from station 2. I will select 2 here and then insert the tool number 2. I said yes. As you can see, the machine will go to the station 2. Automatically, whatever you see here is exactly happening to the real machine in the workshop right now because they are connected. So you see, it will put the first tool to its own position and it will recall the tool from station 2, which was for us, it was our drill. Yes, but because I don't want to start with this tool, I will again return back to the tool number 1, because first of all we should start with the end mill with the 2 mm, and then we will use the drill to make the holes. Again, it will make a position to the station 2 and it will take it from station 1 . So now everything is ready. Also, you can start while the arms and spindle in this position, because immediately when you write the G00, it will come to your 0 position that you defined before, and it will start the process from there. Or you can make it get closer to that position and then start your program. It doesn't matter generally. So, but for here, I will say go to my own 0 coordinate. So it doesn't matter which method you want to use. This one, in the beginning, even if you start to write the code, it will come automatically down and then they will start the position, the code actually. Or you can come to the 0 position that you define by yourself and again write the rest of the code. So both of them are okay. So again, I will make it to 0, 0, 0. So sometimes when it happen like this, it's better to go to the home position. I will make it a quick, and then from here I will write 0, 0 and 0 position. Yes, you see, sometimes if you realize such an error, the best solution is to go back to the home position and again write your 00 position. The arm will go there, or you can start immediately when you press the home button. You can write your code because you started with G00. Automatically, it will come here, and from here, it will start to do the rest of the process. So, this is our ideal position now. So now everything is ready for us to write the code. So first of all, let's me look here. We can make it in a different way, of course. For example, maybe for you and your friend, the code will be different. For example, we want to start from here to here, then from here to here, or maybe another students want to start from here to here clockwise, or some people will start counterclockwise. This is totally up to you. But be careful that as an engineer, you should just try to minimize your movement and minimize the arms movements in order to increase the lifespan of the machine. But for this shape, because it's a circle, actually it doesn't that much matter. Is go from the left to right or from left to right, clockwise or counterclockwise. So, but for me, I will go for from here to here first. But in the beginning, where we should start, because right now we are located in this position. To start to make the shape, actually I should come to this point, yes? So what is the position of this point? My uh, white is 80 and this point is in the middle. It means the x. This is x and this is y axis. So when this 80, the middle of it is definitely is a 40. So my x is 40. So what it will be this position in y-axis? Because y-axis is 60 as a white. So this point is the center of the circle is definitely it will be 30. 60 divided by 2, it will be 30. So how much it will be this point? This circle is here. What is the radius, first of all, of this whole circle? As you can see here is 40. So because it's 40, we can realize that the radius of this from here to here, it will be 20. Okay? So 30 deducted by 20, this will be 10. Okay, very simple. Just you should realize it by some simple mathematics, the correct position. So x is 40 and y is 10 because half of the circle is 30. The radius of this whole circle is 40 divided by 2 is 20. So 30 deducted by 20, it will give us y as 10. So we should first go to this coordination before we want to start the rest of the position. So we will write it G00 because it's a linear interpolation. Go to the X 40 and Y 10 with which is space, for example, as a safety distance between the tool and the machines, because you see, for example, here we cannot do the movement because it can scratch it. So we should go first a little up, then moving to the, so I will give it by myself, for example, 5 millimeters go up to don't damage the you know, the surface, and I can run the program now. Let's see how it's gonna work. We will click this red button, yeah, green button, and we will make it as a, as by the way, when you click to this green button, as I wanted to say about the color of this, by 3D verify setting, if you click, you can also, you see, change the color of this specimen. For example, what it will be like this setting. You can also change, if you have a problem here, you can also change the white and dimension from here, or the color from this one, you can make it from here, but for me blue is fine. So I will run the program. You see, now the program is stopped. Let's see the position from the side. You see, now we are in a correct position of this point that we want to start. See, now we are exactly in this position, guys. So now it's good. Everything is ready for us to start the second line. So what we should do now? So of course, because the spindle now is turned off, when we want to go depth and start to make the shape, we need to start our spindle. So what was the code for starting, turning off and turn on the spindle? It was M03. Now what we should do to define the spindle speed. So it can be between 1000 to 5000, but because our specimen is a plastic, we will go with 2000. I think it will be enough. It's the speed of the spindle. So now, sorry, I forget to put S here. It will be S, it means spindle speed. It will be 2000 RPM. So after that, when it started to work, it means it started rotating. Sorry, I will make it here. Yes, next line. So now I want to move linear or circle movements. Of course, is a linear. Sorry, is a clockwise and counterclockwise. But first of all, I need to be depth. First of all, before I define it as a which side I want to go, this spindle, when it start to turning and turn on and to rotate, it should go depth first and then start to do clockwise or counterclockwise. So for this reason, I will write G01. How much we want to make a depth down? For example, because now we are 5 up, when we come 5 minus 5, it will be on the surface 3 millimeters more to be a little depth. So I will make it as a Z minus 8, for example. And what is the feed rate? Feed rate is the movement of the arms per millimeter per minute. So I will make it 200, which is up to you. I don't want to make it fast to be older in order for us to see the movements of this tool. So now it's ready. So it will, after I set the run, now we are in the position, it will start from here, the spindle will be turned on, and then it's go deep with this feed rate, is ready to move to the next coordinator. So for me, what is the next coordinator? Because I want to go with the counterclockwise. If you remember, it was, what was the code, G code for counterclockwise? So by the way, it's good, I remember, if you don't have your note or you forget the codes, this software has the best dictionary for the codes for you. You will just come, need to just come to help, click on help. So you will go to the CNC programming, NC codes. So you will see G codes and M codes. All of it is here. So if you need to go for linear interpolation, it's G01 circular interpolation. So CCV, it means counterclockwise. And this is G02 is clockwise. Everything is here. Even if you click on them, you will have a very good description of this code. And you will realize that for your specific movement, which of this code you actually need. This is a very, very complete, like a dictionary for the G code, and this is also the M code here, for example, M03, you see here, we just use it to start the spindle turn on. So GZ spindle on. So you see, if you click, for example, you can NC code, everything is here for extra, or M05, M06 tool change. If we need tool change that we need when we want to change it between the mill and the drill, we should use M06. So this is a very good guidance for you. So I will close it. So by the way, now I need to move from here counterclockwise to this point. So when I'm moving from this point to this point, does my x is gonna be change? No, x is same position. Only thing it will be increased or changed, it will be y. Y is here, it was 10. When it go here, it should be how much? Because the whole circle is 40 and we are in 10 here. 10 plus 14, it will be 50. So I should write G01 linear interpolation. Then I will go for counterclockwise in y15 with the radius of 20, because this part radius it will be 20, because uh, whole circle is 40, radius it will be 40 divided by 2, it will be 20, as you know. So you will write it here G03. So y it will be 50, the next position, and the radius is 20, because radius is mean the whole is 40 divided by 2, it will be 20. That's it. Now we are in that position. Again, let me go back to the map. Now I'm here. I need to return back to my previous position, but this time still counterclockwise. If you start from this side, you will use clockwise codes. So now I'm here. If I want to come from this point to this point, does my x gonna change? No. The only thing is gonna change is my y again. So from 50, again I will return back to 10. So simple. So let me write it again. G03. I will go back to my previous position to make a perfect circle, y10, with the same radius, r20. By the way, if you want to verify your movements before you started on the real device and to damage the specimen, or you are not sure, you want to get sure, this is the best method to use the verification. You will see here what will gonna happen in your specimen before you want to start. By here, if you see verify, you can make it and you will verify the program. You will see here, you see I did a perfect circle. Very nice, very good. So it means that my code is gonna work correctly. So this is a very good option for you to check before start the main program. So next time, now I'm in this position. I made a complete circle. I move from here and again I return back to this point. Now it's time to do this small circle. So one of them is clockwise from here to here, and from here to here is, sorry, here is counterclockwise again from here to here, and from this point to this point is clockwise. So how much is the dimension? So here we wrote it from down part in the beginning part. So again, I want to go for that this point in a small. So this is small one. I need to find the actually the radius of the small circles are 10 is given here. So the radius are 10. So if I want to move from here to here, again my x will change or not? Of course not, because it will not change the x. X is still in the same position, just only y will happen. So now I know this position is 10. What is this position? Y. So because you remember that this is a circle and the height is 60, the half of the circle is 30. So I want to move from here to here. Only my y will change from 10 to 30. So I should go to the y 30. Very simple. I will again use the G03 as a counterclockwise movement. I want to go for y 30, but this time because I'm on the small circles here, the small circles, the radius for the small circle is 10. I will make R 10. Okay, then even you can see, you can verify it again to see how it's gonna work. You see, it will make a, it's very good. Again, it's made this a complete circle and also the half of a circle. It's correct. Then where I am, now we are here. I want to go from this point to this point. So, but this is a counterclock movement. This is 30. I want to go to this point. How much it will be? 50. Because if you remember, this was 10. 10 plus 40 of the whole circle. So 10 plus 40, it will be 50. Because this 50 will count from here. Actually, this is our 0. And this is 10. 10 plus 40, it will be 50 in this point. So I will go this time because it's clockwise, G02. I will go to Y50 again with the radius of 10 because still I'm in the small circle. So let me again see the verification. Verify, you see, that's perfect. So as you can see, everything is gonna be okay. So now I did this, my circle with the small circles and the main circle has finished actually. So now I need to move up, uh, come up from the specimen, from the depth, I will come up, and I need also to change my tool because now I need to do this two hole with the diameter of 10. So I should change my tool from this station and check the tools from station 2. So first of all, we will go back to the 0 position but with a little high from the specimen to don't damage it. So I will return back to the G00 and Z I will get 10 plus. It will go, sorry, this is 00, G00, and Z it will be 10 come up because it was -8 on the specimen. So I should put something positive even more than this to come up in the surface even a little more with the safety distance between the surface of the specimen and the tool. So then when I come up from the depth, I need to change the tool. What was the code of the changing tool? We just checked it on the dictionary in the help section. It was M06. And where is the tool located for me? In the station number 2 here. So it will be T2. You can write it even T02. It doesn't matter. Or T2. It will work. So now the machine will go and it will change the tool. So now I need the position of this and this small circle to make a depth. So again, after we change the tool, we will again return back to our 0 uh, position, guys, that we wrote it in the beginning. So again, we will come to where was our this position? Actually, this is not our 0 position. Sorry, this is this place, the first place that we start the operation. So we want to again come here, and from here we will define these spaces for these two holes. So what was the coordination of this point? We wrote it here in the beginning. Same scenario: G00, X40, Y10, and with Z5. Well, this time I will make the Y20 because why? I want to shorten my coding. You can come here and again come here, but is it necessary? No. You can directly go to this center. So what is this position? If it's 10 and this is 30, because it's a half of the circle, 30 deducted by 10, it will give you 30. So 30, it will be the center of the small circle. I want to just shorten my uh, lines for G coding. So I will make it Y20 instead of Y10 because I want to come here, because Y10 is here, Y20 it will be here. How I will find this 20? 10 is here and this is 30, half of the circle. 30 deducted by 10, it will give us 20. So for this reason, I wrote here 20. Then I need to do G01 is a linear interpolation because we want to move strictly. Depth was the depth that you choose, it should be same, that the shape should be the same size in every dimension. 0.8. Again, go down with 0.8 depth to do the uh, the holes, and G00 it will with the depth of Z5 because it was Z5 before. It will go less than -3 down even to give a shape for our movement. So then when it get finished, when it do the first hole, again it should return back, it should come up the tool. Then when we are here, when we do the drill, again the device should come up to the surface, move to this part. If I want to move to this part, do I need any x's or x will change? No, again just the only y will change. What is the y here? So simple, because here it was 40 and this place was 30. Again, because it's a half of the circle, 40 divided by 30, it will be 10. So definitely this point for us is a 40, y 40. I will make it as a G 0 0 y 40. Okay, I came here from, when it's finished from here to here, it will be this point, this middle of the small uh, circle is 40, because this part, if you remember, it was 50 and deducted by a 10, it will be 40, because the radius of this is 40, it will be 10, it will be 40. So why it will be 40? So when I'm on the top of the second position and I want to make a hole, deep hole, again I will make the G01, the linear interpolation with the depth of same, again deducted by Z, it will be -8. It means 8 millimeters is go down to the specimen, depth on the specimen. And finally G00 with the Z40, it will come back. When it's finished, it will come very top up from the specimen, because the job it will be finished. And if you remember, when everything is finished, we should shut down the system and the machine with the code of M30. So seems, it looks, everything is gonna be perfect. So we will just run it and let's see what will going to happen. So I will go here to the green one. When the code is finished, I will click and run the program. The request is stopped because I should start it from the top. So first of all, let me go to the home position. So I'm actually, maybe the door is open. The door, let me check. Door is actually closed now. Uh, I will again run it. Move away. So let me delete this last line. Maybe it's because of this. It will not Gonna work. Let me check the. So that one was not a problem, M30, because after we finish, we should uh, let me verify it and see how it's gonna work. Yes, and go in. I want to verify it. I will use this verification box. Now it said enter tool 2. It said yes, go for it. Normal problem will start. You see, so everything it will be perfect if we're gonna run the program. So, but let's see how the program gonna move. Now it's started to move, guys. You see, let me go further. Yes, you see, now our program is working. Don't forget the door should be closed, otherwise it will not gonna work. So spindle is turning. It will do exactly, you can see it here as a simulator. It will doing the perfect circle. I cannot open the shield because immediately when I open the shield, the system will stop to operate because of safety. So we will go inside to have a better view. So now is perfect circle is going to be finished. It's exactly going according to our codes. Now for the small circles. Yes. And clockwise. Very good. So you see now the circle is finished, small, and the big circle now is going for the tool changers to make the holes. Automatically it will go to first put back the first tool to the station 1 and recall the second tool from station 2 to make the holes for the small circles in our map design, the shape that we want to make. See the first one, spindle is working. And by the way, when you just write one time here, the spindle is turned on, it doesn't need to make it again, because when this you have a tool changer command in your program, automatically it will turn off. It will go to change the tool, and when this changed it again, it will spindle will start to work with the same information it was before. And that's it, guys. Congratulations when you make it. This is the first time you make some shape or design in your specimen by the CNC machine using the G code. And everything you see, the spindle now is turning off because we get M30. And even now we can open the shield, yes, to check our specimen from the more closer view of sight. So that was our simulation G-code lab. I hope you enjoy it, and you can watch this video over and over if you have any problem during this process for your homework. And if you had any questions, you can ask me during the lab sessions. Thank you very much and good luck to you all.